I hope everybody's doing okay. This is going to be a long video, so this is a warning, so to speak. And I hope you stay with me on this one because we'll be dealing with a lot of things. There's a bunch of things that are coming together in this one specific video, and it's going to be a long video, so that's for sure. But let's see how far can we go. I'll see if I could break this down into different videos or keep this as one. But what we're essentially trying to do here today is set up hypothesis testing. We're going to do a demonstration of this and see what are the steps involved. And I might, write them down in this sheet somewhere around here. I'll try to fill in as we progress, and at the end we'll have a look at this. What are the key steps involved in hypothesis testing, right? But one thing is for sure, regardless of whatever you're trying to do, you would want to have a null hypothesis and an alternative hypothesis, and you would want to frame them, right? Specific statements for them. Based on the videos that we have previously had and we have content that we have covered, we've basically been dealing with the mean values, the average values. We have ignored proportions, we've ignored any other cases. We have specifically looked at average values, right? So if I am to construct, for an example, a null hypothesis for, say, happiness index, right? Um, yeah, happiness index exists, tells you how happy people are in a country, right? And there are rankings for different countries. So what I'm trying to do is understand how we could frame that as a null hypothesis in our case, right? So because then we would be needing a mean value, so to speak, for this statement, right? So again, if I were to do this, I would possibly say on average, and I'll actually go ahead and write this down. On average, might as well just type it. Okay, I'll just write it down. On average, uh, Pakistan citizens um, have a score of uh, some number on happiness index, right? I'll zoom out. Have a score of a number on happiness index, right? The handwriting is not the best, but I am speaking this out loud also. So on average, Pakistan citizens have a score of this on happiness index, right? So that is my null hypothesis. And an alternative hypothesis, if we are doing a two-tailed test, would simply be the same statement, but is not this number, right, on happiness index. And the rest of the statement is pretty much the same, right? That is what makes it a two-tailed uh, hypothesis uh, test, right? Because we are saying, okay, on the base case, this is our ranking, our score, or our average value, so to speak, on happiness index. But the alternative hypothesis is it's not. And then we then take samples and we conduct a survey to prove or basically reject or not reject the null hypothesis. So that's the idea of it. But the key question here is, where do these numbers come in from? What is the average value, or what is the average value corresponding to the mean value or corresponding to the null hypothesis? What is the mean value corresponding to the null hypothesis in this case? What is the average and mean value corresponding to the alternative hypothesis for this case? And how do we build um, our t or z values and then translate them into p values to make an eventual decision? Remember, this is our step one, right? But our step two then is computing the test statistic, right? So we don't know based on the number of samples we get, etc. There is a test statistic that we would need to compute, which is, as we are very well aware, something like this, right? X minus mu over sigma 100n. At this point, we are pretty confident that this number is a mu value. What is it is something we've got to figure out. Yeah, this number. and then there is going to be an x value that is going to correspond to uh, the alternative case, right? And that is the bone of contention here. That is what we are trying to assess and evaluate. Um, Based on the survey answers we get, we are going to compute this x mean value. We will have a standard deviation on the sample, number of responses we get on our survey. We'll get our n over there. We'll see how we are going to handle the mu value, the null case, the status code, the default case, the average value on the happiness index for Pakistani citizens, using that for the null hypothesis. That's the mu right there. So we're going to plug in these numbers, see if we can compute a test statistic. And then the test statistic is supposed to then translate into what's called a p-value, right? So we'll try to see if we can get a p-value for it. And if this is less than alpha, which is the test significance level that we set out on, we might as well set it to 5%, 0.05, because this is something that we set, right? We set it out to 5%, 0.05. We'll compare our p-value to this alpha level, and if our p-value is less than alpha, we will have a very simple decision, which would be to reject the null hypothesis. We will go into the interpretation towards the end. What p-value do we get, and what does that mean? Rejecting the null hypothesis, right? Uh, so that would be a two-step basically process for hypothesis testing. But let's say get down and fill in these numbers, and let's build on our understanding so far. We are looking at happiness index, filling in Pakistan. It's a simple Google query that I already have set up here, right? Pakistan happiness index 2024, some results, some AI-based results. That's okay. Probably picked up from some report. Finland topped it. Pakistan ranked 108 out of 143. Uh, and that is important information, ranking 108 out of 143, right? So this is something that I would want to do here, ranking 108, total 143. Uh, but what is this number, right? In terms of this being total, it's at 0.75, right? So this is scaled from 0 to 1, right? 143 out of 143 would mean 1, 0 out of 143 would mean 0. So this is scaled between 0 to 1. And if I wanted to scale this between 1 to 10, there's a reason I'm doing this, because, and as we will make our survey questionnaire, we'll see setting values from 0 to 10 are easier for respondents to work with and give their opinion on, rather than have them in decimal numbers, right? So this would simply entail multiplying this number with 10 then, because it's already scaled from 0 to 1. Multiplying this with 10 scales it between 0 and 10. So I'm happy with this number. I'll just reduce its decimal places and set it up to one decimal place. It's okay, it rounds off. But this is my number. This is something that I am keen on playing with. But more importantly now, this number is the ground truth. This is the report, right? It's also been done on some tests. It's also been done or obtained based on a bunch of metrics. Obviously, people's happiness is just not based on their opinions. It's also based on real data, right? Income, for example, or other metrics that would contribute towards that happiness score. So um, all of those things do contribute, but we do have a number, right, which we could now use as a mean value. And this is something we're testing out, whether or not the people we're going to question, people we're going to ask their opinion on, do they agree with this number, or is this number not credible enough, right? So these are some of the questions we could answer with this hypothesis testing. It's a two-tailed test, so it could be greater than 7.6, could be less than 7.6, but this was something that would depend on what people or the respondents come out with as their answers, right? So we'll frame that question also. But here, at least I know now that my mean value, or the value that I'm going to use as a ground truth as a status quo, corresponding to my null hypothesis case, is in fact 7.6, right? So that is uh, a number that I would be using here, 7.6. Okay, so I've got my mu set up here. It's a stretch, I understand, but this is something we can use. For the alternative hypothesis, we do not have a mean value to compare this 7.6 against, right? Remember, we're doing a two-tailed test. We do want to, see where do we stand, what are our p-values, etc., and how far away are we from the center, right? So we do need this sample mean and then a standard deviation to compute the test statistic and come across our p-values. And for that, we need the x value right here. So let's go ahead and do that. For that, we would need to conduct a survey. Now, conducting a survey and taking people's opinion. Now, we know we're asking people about their happiness, but then we're scaling it from 0 to 10. This is something we could do on what's called a Google form, and it's a straightforward thing. You go ahead, write Google Forms in Google, you'll come across a link such as this. You're typically the first link. It'll open up Google Forms. There'll be an option, go to Forms. Go to Forms, and you could choose a blank form, right? The very first here, plus sign, a blank form, and you could choose a blank form. The blank form here then gives you a bunch of options that you could configure, right? And the very first one that you would want to do is happiness score survey. Choose a reasonable title. Copy this. Probably also want to name out. It comes out here automatically. That's good. So that in my repository, I could always access it again. You might want to add some form description. I'll leave it for you to do it at a later point in time. Of course, you could color it as per your liking. What kind? The important thing about a format, the essence of it is that you want to obtain people's opinions, right? So you want to make it accessible. You don't want it to be cluttered too much. And in our case, it's pretty much one question, right? So, um, and once you hit this option, you could see there are different types of questions you could ask, right? Short answers, paragraphs, checkbox, etc. One of the things that I can see right here is a linear scale, and that is something I am keen on choosing because I can then choose from 0 to 10, right? And I could tell them 0 means what and 10 means what, right? And this is an important one because what is 0? Is 0, and what is my question? Obviously, a lot of this depends on that. And let's go ahead and frame that question. For clarity, let's also tell our respondents, on a scale of, I know it's evident from here, but they might want to, they might, it's a good practice to also write this down. On a scale of 0 to 10, what is, it's not a question of how happy you are, it's about their perception of the happiness index. So 0 to 10, where do you think Pakistan stands on happiness index, right? I might as well just select all and bold it. And then to answer this, they would want to put in a number, right? So they want to choose a number, and we could see how our form looks like. But let's just also put in what 0 means and what 10 means. So how do we decide this is basically dependent on what this number meant. So 108 ranking out of a total of 143 meant, 143 was sad actually. 1 was the happiest. Okay, so 7.6 means you're closer to 10, you're closer to sadness, and 1 is, or 0 is happiness, right? So it's kind of like an inverted scale, but you could always switch it up, but it's important that you keep track of what you're looking at. So 10 or 143 then means sad, and 0 means happy, right? So 10 would mean sad, or uh, and then 0 would mean happy, right? Where do you think Pakistan stands on happiness index? 0, most, we could say most happy, and we could set it up as, in fact, let's just use these forms. Happiest, saddest. Okay, so because it's a scale, right? But depending on whatever you choose, there's always an option here to preview, right? So you could click that, and this is what your form looks like. Okay, and they could choose one of these numbers, etc., and then they would submit, right? So, and this is what the form looks like. On a scale of 0 to 10, where do you think Pakistan stands at happiness index? Saddest, happiest, right? And people could choose and hit submit. Notice asterisk, which means that you will uh, have made this a required question. You don't want empty entries, right? So by default, you could force this so that you get a response every single time. Once you're done with this, you could choose a bunch of settings. Yes, you're accepting responses. Make sure this is ticked. It's not a quiz. You don't want to collect emails. It's a good habit to keep it anonymous. Do not allow response editing. It's only one question, no need to progress or shuffle, etc. Show link to submit another response. Not really. They're happy. They already had the one link to submit it. That's fine. Do not collect email addresses and make questions by default. So you're pretty much all set with the settings right here. So there's the survey, quite frankly, is ready to go, and we could hit the send button, shorten the URL, and looks like this. This is still a bit still too long. So I would typically go to bit.ly. It's a free service, helps you generate shorter links, and this is something you could then generate. And I'm actually going to send this to a bunch of kids who might be they're probably not keen on answering this, but I might get a few responses if I'm lucky. So let's see. Bit.ly slash 3uv 9 v61. Okay, fill this and hit react when done. So I'll know if I have a bunch of responses. Let me also click the link and see if it's working. Doesn't seem to work. Well, let me copy and paste it. Yeah, it links it to the form, and yeah, it works. Okay. All right. So while we get these responses, we'll wait up on them and see how we get responses, if at all, and then we'll build up from there. Otherwise, we'll just manually fill in a few responses, and that's fine. But remember what we are essentially looking at. If we are hitting more than 30 responses, we're looking at a normal distribution. Less than 30 responses would then take us to a T distribution, right? So it depends on what that is, but let's go ahead and formulate this test statistic until then, right? So let's set up these values. Let's set up x, let's set up mu. Might as well see if I can get a mu somewhere from the equation. Backslash mu, do I get, yeah, I do get this. I will increase its font size, remove this mu, use this around here. Okay, so I will have x, just use x here. Okay, so mu I already have as 7.6. X is something I'll compute from my respondents. Sigma is something I will get from my respondents also, right? So sigma is also coming in from the respondents. What else do I need? I need the number of, I need n, the number of respondents, and that should give me my test statistic. Right, so let's just call it test stat, and this is actually going to be x minus mu, and I will be careful putting in the brackets right here. Yeah, x minus mu over sigma over under root n, this number. Right, so that will give me my test statistic value. And what would be my p-value then? P-value in case of normal distribution, and then there will be a p-value if there is a t distribution, right? It depends on what my n is here at this point in time. And we might as well use some random numbers just to uh, see how we do not have any responses yet. So we'll just use some bunch of random numbers. In fact, what I want to show is, might as well just fill in, submit. Response has been recorded. It's perfectly fine. I'll copy this link, paste it again. Fill in another number. I'll just use 5 responses, because I know the t-distribution is valid for even 5 samples. Of course, my degrees of freedom gets reduced, but that is why we have the t-distribution in place. All right, so okay. In Google Forms, you get these responses and you get these numbers that which look like this. And once you have these, one of the things you do is you get this option to download your responses, right? And you could download these responses, save them somewhere, and after saving them, might as well want to open them and open your zip file, and then you will have this CSV. And once you have the CSV, this is what their responses look like, right? And you have this responses, and it's okay to go ahead and compute your average right at the end. So this right away tells me my average is 7, and might as well compute my standard deviation also. I'll use the sample standard deviation because these are samples, right? And this is 1.82, right? It's 7 and 1.8257. That's okay. I come back to my Excel, and my X is 7. I had 4 responses, and 1. What was this? 1.8257. Okay. You could be very exact about this. You could choose equals to here and go into this sheet and hit enter, and it will pick that value also from a different sheet. So now I have this as an accurate value, but it gives me my test statistic, right? And it's possible that we have a negative test statistic. That's perfectly fine. The reason for that, by the way, is because remember, this was a two-tailed test. It was possible you could be ahead of 7.6 or below 7.6. So in terms of the average values, right? So that's okay. You could be on either side. But you have your test statistic here, and we are going to call this as a t-value at this point because the samples are less than 30, of course. I'm going to do away with this. So this is now a t-value. And since we have a t-value, we can proceed in computing our p-value, which will come from a two-tailed t-distribution test. I will use my test statistic, and there's one catch here, especially for negative values. We'll see if that comes up. And then the degrees of freedom is 3, right? This gives me an error. Why? Because this formula, this is that catch, formula for two-tailed test is expecting a positive number. Okay, so even if our test statistic is negative, or the p-value here is negative zero point 0.6, even if this is something as negative 0.6, we do not really uh, care about this. We could, because this is symmetric, we could use a positive zero point 0.6 and we will still get the p-values here, right? So instead of feeding it the negative value, we'll use the positive value, and it's a two-tailed t-dist formula. It gives us p-values for both tails. So we're going to go ahead and, maybe multiply this with -1 times this, so it makes it positive. I just multiplied -1 with this negative number, it became positive. So that's okay, but we have a p-value, so to speak, right? And then, and since we have this p-value set up, we can see this is a very, very big p-value, right? We see this is 0.587, and this is something we could actually write this down somewhere around here. I think we have, yeah, 0.587. Uh, so since this is a big number, and that's okay, we're just doing this as an example, you would have more realistic numbers, and that's fine. We could right away make the conclusion, p-value is not less than alpha. P-value is not less than alpha. It's actually greater than alpha of 0.05. So we cannot reject the null hypothesis. Okay. Um, but that's one idea. What I want to do next is then, have a better visualization for this. Um, Notice, what did we get? We obtained 0.6, and this number is it's a big number. Minus 0.6 and minus 0.6 corresponds to a big probability, 0.587. Okay, and this is greater than 0.05. So if I were to draw 0.05 on this, let me also mark these. What would this area be? And what would this area be? Remember, 587 is the sum of both of these, right? So there's something half of it, 0.29 here and 0.29 here. So that's, together they make 0.58, right? So this t-value is giving me these areas, these probabilities, and if I look at alpha, I would say somewhere around here is alpha by 2, somewhere around here is alpha by 2, right? So this smaller area and this smaller area, this would be 0.025 and this would be 0.025. Together they would make 0.05, right? But this is something we're doing manually, and what we would be more interested in is doing something on uh, on Google Colab to get a formal plot. And one of the things we could do is we could use ChatGPT for this, and we could request it to provide a Python code to plot normal distribution curve with t-values specified on axis. Prompt engineering is in itself a very complicated domain, something we could talk about at a different point in time, but we would want to be a bit more specific talking about this, right? So we're looking for a normal distribution curve, t-values specified on axis, and relevant p-value shaded. Okay, this is probably something I would want a Python code that I could use off the shelf and basically work with. I see this is given me a functions based implementation. Might not be so keen on using that because I would want to play with it, but okay, let's just go ahead and use it, take it for its face value, and go ahead and plot this. Paste this on Google Colab. Again is query on Google, gives you the first link, Google Colab, and then you choose the new notebook. Should give you a new fresh notebook. Connect it, paste this right here, run this code, and it gives me something like this. This is the code that we just obtained. And then our idea here is then would want to do away with the grid. I'll just make it false very quickly and have this execute again. And then this is not the t-value that I was looking for. I was looking for 0.58. No, my 0.605, right? So that's the t-value I'm looking at. 0.605. So that is the t-value that I am looking at, and it corresponds to 0.54 p-value. What did we have? 0.58. Okay, probably some calculations that we would want to fix, or maybe we could ask GPT to give us specific, follow a specific t distribution, etc. So we could work on that, but this is something that we can easily obtain. Then we can mess around with a bunch of things, shading colors, etc. Work on aesthetics of this, and go back and forth with GPT and this code and try to deal with a bunch of things here. I'd probably not want the title shown when I use this figure in a report. I would probably have this title separately mentioned. Don't want to do probability density. I already know working with areas under the curve. What else can I look at here? Maybe have this as a black, and then line width I can play with. There's a bunch of options I could actually work with. But in addition to this, what I would also want is my alpha, right? The threshold to be shown as well. And I am noticing I do not have the option here to work with it, perhaps. This is a two-tail and we already have this. Maybe I could ask GPT again to uh, incorporate alpha 0.05 threshold region and implement without functions. Just to keep it simple so we could mess around with it at our ease, perhaps. Right, so here, without a functions implementation, I can see my t-value, I can see the alpha right here, and I could change these around and see what the implementation looks like once I mess around with this. So these kind of commands would probably come in more handy, and I will just take this off face value, copy this, just go to a new cell, and paste this command or control enter, and that should give me my plot. So this is the 1.96 and 0.05 is oh, they are overlapping regions. Might as well just change it very quickly. Let our t-value be the test statistic 0.605, and then run this and see what do we get. Okay, yeah, the colors are overlapping. Seems to be red, and let's just change this color just a little bit. Okay, I'm going to change alpha for green, and this is red, but I'll have their uh, intensities set up. It gets hidden behind, so might as well choose it Okay, yeah, we reduce the intensity of that. So let's also keep this so it's readable at least. Right, so basically point being you could choose these different colors and intensities and then have this plot set up here so you could tell where its p-values and what's the critical region under which, had p-value been, you would be rejecting the null. But since the p-value is greater than this alpha region, you cannot reject the null hypothesis, and therefore you in your two-tailed test you choose to not reject the null hypothesis. So that is pretty much an overview for this. But let me add just two more bullet points on this, which is the third idea here is doing a survey and using those results, right? And then the fourth idea that we worked on is quite literally plotting p-values and alpha. And for that, we used Colab and Chat GPT to obtain the code, right? So this is something that we worked with. So in a nutshell, this is a working example that use happiness index of a specific country. I filled in some dummy entries, but you will of course might want to use real entries, see what numbers we get, and based on that, reject or not reject the hypothesis. Now, the important point that I want to end this video on is quite really the heart of it, which is the interpretation. How do you interpret this? You had a null case, you had a mean value 7.6. You went out to see whether or not this is true. The alternative hypothesis was then, no, it's not 7.6. That's not how sad people are in Pakistan. And then, based on the entries you got, we obtained a mean corresponding to x, which was 7, right? It turned out to be 7 based on the 4 entries we had. And the test statistic was zero point 0.6, right? It corresponded to a p-value, which was greater than alpha, and we concluded that we cannot reject H naught, meaning that we do not have sufficient evidence, or the evidence that we have is not statistically significant or statistically significantly different from the null case, the 7.6, right? The 7 that we have obtained as the mean x value is perhaps a coincidence. It's probably not reliable. It's certainly not very reliable. We only had 4 entries, and that too were dummy entries, but 7 is far off from 7.6, right? And it matters. Uh, on a normal curve, this matters, right? Um, we had a very low standard deviation on this because of the 4 entries only, about 1.8, yes. So based on these numbers, we do conclude that we do not have statistically significant um, evidence to reject the null hypothesis. Therefore, we cannot reject it. We will stick with 7.6 mean value, and the two-tailed test proves that it's credible to stick with the null hypothesis and not reject it. We're happy to take any questions in the comments, and then we can build up our discussion on that. Thank you for staying and listening. I'll see you in the next one. Bye bye.